You know, when you're standing there at the gas station, pump handle in hand, just waiting for that click.
Happens all the time.
Most of us, we just see the nozzle, the screen, maybe the card reader. But do you ever really stop and think about what's actually going on inside that machine?
Probably not much, no.
Yeah, it feels so simple, right? Just pumping gas. But the
Mhm.
reality is it's incredibly sophisticated engineering working away behind that metal casing.
It really is.
So today we're doing a deep dive into something we all use constantly, but, well, maybe take for granted. Those ubiquitous Gilbarco fuel pumps.
You see them everywhere.
Exactly.
Yeah.
And our sources give us a really detailed look at how they work, what's inside, and I think you'll find some surprising stuff about this everyday object.
Yeah, our mission here, for you listening, is really to peel back those layers, to look at the technology, the safety systems, the sheer precision that's packed into these things.
Right.
We want to move beyond just, sticking the nozzle in the car and really understand the complex engineering that makes it all happen smoothly.
Okay, so let's start there. Gilbarco. Why are they such a big name? What's the main job of these pumps?
Well, Gilbarco is definitely a leader globally, and their core purpose sounds simple, but it's actually a huge challenge: delivering fuel accurately, safely, and efficiently every single time.
It's more than just a hose and a trigger, then.
Oh, absolutely. These are sophisticated machines. They're built for really high reliability, incredible precision. That's why you find them at so many gas stations all over the world.
All right, let's unpack that then. How does the fuel actually get from that big underground tank up to the dispenser where you are? What are the key bits inside making it work?
Okay, so it all starts with getting the fuel moving. Older systems sometimes use what's called a suction pump system. Basically, a motor up in the dispenser created a vacuum to pull the fuel up.
Like drinking through a straw.
Kind of, yeah. But most modern stations you visit today, they'll almost certainly use a submersible pump system.
Submersible, meaning the pump is actually in the tank.
Exactly. Down in the underground storage tank, there's a pump that actively pushes the fuel up to the dispenser.
Ah, okay. Why the change?
Well, submersible systems are generally just more efficient. They can move fuel faster, and they cut down on problems like vapor lock, especially in warmer weather. It's just a better system overall for modern needs.
Makes sense. Okay, so the fuel is getting pushed up. Now, the really clever bit. How does the pump know exactly how much fuel it's giving you? Down to the hundredth of a gallon, it's always spot on.
Yeah, that precision is critical, isn't it? It really boils down to two main components working together. First, there's the meter.
The meter, right?
The Barco uses what are called positive displacement meters. Now, you can sort of picture this like a tiny, incredibly precise engine or maybe a set of interlocking gears inside.
Okay.
As fuel flows through, this mechanism turns, and each rotation corresponds to a very specific, tiny volume of fuel passing through. These things are built for amazing accuracy, and they last a long time.
So it's physically measuring tiny amounts.
Exactly. Then, connected right to that meter is the pulsar.
The pulsar.
Think of the pulsar as like the meter's accountant. Every time the meter turns measuring that tiny bit of fuel, the pulsar converts that mechanical rotation into an electrical pulse, a little digital blip.
Ah, so physical movement becomes electronic data.
Precisely. And these pulses are absolutely crucial. They get sent straight to the pump's computer, which counts them up to calculate the exact volume dispensed and, of course, the price you see changing on the screen. The engineering just to measure liquid flow accurately is pretty neat.
So these pulses, this data stream, where does it all go? What's the brains of the operation coordinating everything?
That would be the control electronics, essentially the pump's main computer board, or CPU.
Right, the central processor.
Yeah. If the pulsar is counting, this CPU is the command center. It takes all those pulses from the pulsar, it talks to the payment system, your card reader, or the station's main point of sale, the POS system. It does the rapid-fire price calculations, it controls what information pops up on the display screen, and it also manages various valves inside the pump to start and stop the fuel flow. It's really the central nervous system.
Got it. And speaking of stopping the flow, that click when the tank is full or when you let go, that's where safety really comes in, right? How does it manage that so cleanly?
Absolutely. Safety is paramount. There are a couple of key things here. First, you have the flow control valve inside the dispenser itself.
Okay.
This valve controls the rate of flow, but critically, it's designed to shut off the fuel completely when the transaction ends, or if the system detects a problem. It often works with the nozzle shutoff too.
And the nozzle itself, that has tech in it too.
Yeah, the nozzle you hold isn't just a spout. It has its own integrated automatic shutoff mechanism. That's what usually causes the click you hear.
How does that work?
There's usually a small tube or sensor near the tip. When fuel covers that opening, meaning your tank is full, it triggers a mechanism that snaps the valve inside the nozzle shut. Or, of course, when you release the trigger handle. It's a vital safety feature to prevent overfills and spills.
That makes sense. You also mentioned vapor recovery.
Right, that's another important feature on many modern nozzles. Those rubber bellows you sometimes see around the spout, they help capture gasoline vapors that would otherwise escape into the air while you're fueling.
So it sucks the fumes back.
Essentially, yes. It redirects them back into the station's underground tank or sometimes processes them. It's a big deal for air quality and meeting environmental regulations.
Okay, so we've got the internal mechanics, the measurement, the brain, the safety. What about the parts we directly interact with? The screen, the payment, and how does this single pump talk back to the main station computer?
Good question.
Yeah.
So on the user side, obviously you have the display unit. We mentioned that's controlled by the CPU, showing you the quantity, the cost, the price per gallon or liter.
Standard stuff.
Right. Then there's the card reader payment system. This handles your credit card, debit card, maybe fleet card, and it's constantly communicating, either directly with the payment processing network or, more commonly, with the station's central POS system to authorize the sale.
And that link, that communication, how does that happen?
That's the job of the communication interface.
Right.
Think of it as the pump's network connection. It needs to securely talk to the station's main system. Gilbarco has its own traditional protocol called G-Site, which is like their proprietary language.
Okay.
But increasingly, modern pumps use more universal standards. You might hear terms like IFSF, that stands for International Forecourt Standards Forum,
IFSF.
or even standard internet protocols like TCP/IP. Using these common languages allows the pump to securely send transaction details, receive price updates instantly, allow remote diagnostics, things like that. It makes the whole system much more integrated and flexible.
Okay, so pulling all these pieces together, let's walk through what happens step by step from my perspective as the customer pulling up to fill the tank.
Okay, sure. It's actually a pretty elegant sequence when you think about it. First is authorization. You start things off, maybe insert your card, or select the fuel grade on the keypad. The pump immediately sends a request to the POS system or the payment network. Is this okay?
And that happens super fast.
Milliseconds, usually. Once it gets the green light, approval, the pump moves to activation. It unlocks the nozzle, primes the internal systems. The slow control valve gets ready. Basically, it's set to dispense.
Ready to go.
Then, dispensing. You squeeze the trigger, fuel starts flowing from the underground tank through the pump, the meter starts turning, the pulser sends signals, the CPU calculates and updates the display in real time. You see the numbers flying
Until
the automatic shutoff. Either your tank gets full and the nozzle sensor triggers, or you let go of the handle. That satisfying click happens, the nozzle valve snaps shut, instantly stopping the flow.
and then the final numbers lock in.
Exactly. That's the final calculation. The system totals up the exact volume dispensed, calculates the final price, sends all that transaction data securely to the POS system, and usually prompts for a receipt.
Wow. When you lay it out like that, it's quite a bit of seamless integration happening in just a couple of minutes.
It really is. So much has to work perfectly together for that smooth experience we just expect. It's a testament to really efficient system design.
Absolutely. Now, beyond these core functions, we know technology never stands still. What kind of smart features are we seeing in the latest Gilbarco pumps? What's pushing things forward?
Oh, there's quite a bit of evolution happening. For payments, enhanced security is huge. You've got EMV payment capability, that's for chip cards, which drastically cuts down on fraud compared to the old magstripe.
Right, the chip readers.
And alongside that, NFC contactless payment. Things like Apple Pay, Google Pay. Just tap your phone or card. Super convenient and quick.
Yeah, I use that all the time now.
Many pumps now also have integrated media displays. Those larger color screens you see. They can play video ads, show station promotions, maybe safety instructions while you fuel. It turns the pump into a bit of a communication hub.
Interesting. What about for the station owner?
Big advancements there too. Things like remote monitoring and diagnostics using cloud platforms. Gilbarco has one called Insight 360, for instance.
So they can check on the pumps from anywhere.
Pretty much. They can monitor the health of the pumps, check fuel inventory levels in the tanks, sometimes even diagnose problems remotely without sending a technician out immediately. It makes managing the station much more efficient.
That must save a lot of time and hassle.
Definitely. And we already touched on vapor recovery systems, but they're getting increasingly sophisticated too. They're a key smart feature for meeting environmental rules and, just being better for the air we breathe. They prevent a significant amount of pollutants from escaping.
So it's not just about pumping gas anymore. It's security, marketing, station management, environmental responsibility, all packed into that same box.
Exactly. These features really show how the pump is evolving from just a utility into a much smarter, more connected device that benefits everyone involved.
We have certainly covered a lot of ground. It's
Yeah,
really clear now that this thing we interact with so casually, the fuel pump, it's actually this incredibly complex integrated system. Precision engineering, sophisticated electronics, multiple layers of safety. It's all in there.
absolutely. And I think understanding the behind-the-scenes tech and everyday things like a Gilbarco pump really gives you an appreciation for the sheer amount of thought and engineering committed to making things accurate, safe, and efficient for us. Technology that most of the time just works silently in the background.
It's true. So maybe the next time you find yourself at the gas station waiting for that click, just take a second. Think about all that unseen technology humming away, working
Mm.
for you, measuring precisely, keeping things safe, processing your payments securely. And it does make you wonder, doesn't it? What other seemingly simple technologies that you use every single day might be hiding similar layers of fascinating hidden complexity, just waiting for you to take a closer look?